Hello and welcome to the Cyber One YouTube channel. In this video, the plan is to wire up the two ultrasonic sensors and a passive infrared detector and mount them in the chest of Inmoov and hopefully connect them to the Raspberry Pi. While removing the chest from Fread, in preparation for that, I discovered that this section here has been under a fair bit of pressure and has cracked. And the crack has continued up on this side. So before we go any further, we'll have to repair that first. So I've removed these two screws that hold this in. I think there's just too much pressure coming in through this area here, and that's making it, and that's what's caused it to crack. So if we turn it over, it's only really spot welded a little bit here, which is why it would crack at the front. It was welded in the front. So let's pull these bits out and get this welded back together. And while that's heating up, these are the two ultrasonic sensors that I'm planning on putting in. I've just put them on a bit of breadboard, and the Arduino Nano I'm planning on using. So we'll program that with the MRL COM first, which will be needed for it to talk to the my robot lab on the Raspberry Pi. And I'll need something to mount the Arduino on for the wires for these to connect to. So I will use one of these boards. I'm thinking more one of these might be easier to use. A couple of strips that will cut to the right length for the Arduino to plug into in case we have to pull it out for any reason. I prepared a couple of wires the other day ready, and we'll solder those on so they can be plugged onto the headers that were pre-soldered on the ultrasonics. And I made up a plug for the passive infrared detector so that it can be plugged in nice and easily. There is a crossover up here that's needed. Because from memory, the voltage on this is on either side. Now on this, they actually put all the labels underneath the cover where you can't get at it. So the middle terminal's the out. I'm using the black as the ground. So this is set up. I have a little experimenter's board where signal is always on one side, ground the other, and voltage in the middle. So this plug's configured for that, and I'll configure it the same way. The same way we do servos. So we'll get all that mounted up. We'll make up the board, program the Arduino, and then we'll put it all back into Fread. Okay, so what I was doing is playing around with the end of the 3D pen to melt all the way around, get the whole area under there quite hot and molten, and then add in some filler, so some more PLA filament, and then squash it all down. It doesn't look particularly pretty from the inside, but it doesn't come up too badly. There is a bit of crack, and I might be able to touch that up with some paint. But I think before we put this middle couple of pieces in, we might just open this up a little bit with a file. It looks like there might be starting to crack a little bit through here as well. And we definitely don't want it cracking up. So we'll touch up along here as well. This is going to be harder because I can't get the nozzle in there. This filament's got a lot of moisture in it. You can tell by the way it's crackling. Okay, so we've strengthened up in here a bit. We've added more welding here. Give it more strength. And I might see if I can get a little bit more in there. Yeah, I think that'll do for our repair work. Let's move on to the Arduino. So this is just a breadboard. I've pushed the two ultrasonic sensors straight into it. I have had a little bit of play with raw Arduino code, so C++, and I have been able to prove both these sensors are working with some simple code. So the next trick is to install MRL-COM. Now, I did try doing this from Fred's Raspberry Pi. The problem is the latest version of Raspberry didn't come with the Arduino IDE pre-installed. So I installed the Arduino IDE using apt-get, and while it installed and appears to work, I happily can see the Arduino. I cannot get it to compile MRL-COM. It keeps reporting it's missing a library. I suspect that's because they've been updating the MRL-COM for the latest version of the Arduino IDE, which was designed around Windows. So I copied the folder, and I will actually bring that up now. Okay, so this is the Raspberry Pi desktop. I've opened up the folder explorer and navigated through to Home Pi. Now I've got MRL Nixie because I've also got MRL Manticore installed on this machine as well. So you can have multiple versions of My Robot Lab installed on the same computer, depending on which one you're using, what features, and seeing what works better. So in MRL-COM we've got all these files. So I've copied all those files from the Raspberry Pi using VNC file transfer over onto the Windows PC. So let's bring up the Arduino IDE. So there's not much to this. There are lots and lots of files. So I just double clicked on the mrl-com.ino file that was in the directory after I copied everything across, and it opened up and rolled everything up to speed. The next trick is to plug the Arduino into the computer, and I did have a cord here. I'll put it away. Okay, so I've plugged the Arduino Nano into a USB port, and on my computer it comes up as COM7. Now, It's an Arduino Nano I'm using, and I've got older versions. I bought a heap at one stage when they were cheap, so they've all got the older bootloader on it. So we're right to program. So this is actually really easy. All we need to do is click on the compile and upload. From uploading to the board. Oh, I've got Cura running in background. So if you're not aware of it, a lot of 3D printers use the AVR chipsets and bootloaders that Arduino uses. So if you're running into problems where you're getting errors, it's not able to do it, check and make sure that you haven't actually got Cura or something silly like that running in background. It will work if Cura is not running. So this is now uploading. It couldn't before because Cura was grabbing the port. And we're done. So now we have the MRL COM installed on the Arduino. Now it's important that you do run the same version of MRL COM as you are running on your computer for your robot. Otherwise things don't work. It has to be the same version. So if I wanted to run Manticore, like go back to Manticore for some reason, I would have to reflash that with the Manticore version. Alright, so next trick is to start mounting everything together. Now it's going to be a lot easier to get the plugs onto these ultrasonic sensors before we put it into here. Now when Gail created these, he actually put holes in the back here so we can reach through with a small screwdriver. Now he has got 4 holes in there, I think. Yep, there's 4 holes in there, so I think I don't have that many of the really small screws I was wanting to use, so we'll see how we go there. But let's make up our board. Now these are too long, so I'm going to shorten it down to suit. These I get from the local electronics shop in Bendigo. I believe J Carr supplied them. You probably get something similar to these from almost any electronic shop around the world. I think I need a little vise. Much easier when the board's not running away from me. That was the easy bit. Now I might grab some headers, and I might actually just, with these, I might put plugs on the other end and make it so I can just plug them into the board along the edge. So I'm just going to stop and grab some headers and we'll be right back. Okay, so these are just standard headers. So we'll set these up on the board ready to go. I've got more than I need here. I need 4 for each ultrasonic and I need 3 for the passive infrared. So we'll just cut off what we need. And 3. Digital pins are all on this side. We're all on this side, so we will put them on there. Now, when we look at our ultrasonic modules, we have got VCC and ground at opposite ends. So we need to pick which end we're going to use for VCC, and I'm thinking we're going to use the head end. Ground on the far end. Then the trigger and the echo will get wired to the data pins or digital pins. So I'm going to get some wire to use as hookup wire. Now we've got these little strips through here, groups of 3. We can use those as our buses for the voltage. So we're going to use this group here and this group here for 5 volt and this group here and this group here for ground. Actually, I might just use this group and this group for ground. That might be better. Now, if you'll remember, I said the middle pin on the group of 3 is the one we want. You'll find a lot of radio control gear is set up that way so that if the person connecting it all up can't see what they're doing properly and they connect the plug-in back to front, it won't actually cause damage to the servo gear because the power pin is always in the middle. If they do hook it up back to front, they're only transposing the signal and ground wires, so it won't cause much in the way of damage. Okay, so let's have a look at where we're going. So there is a ground over here, which is no good to us at this point. Ground 5 volt over here. So that's our 5 volt. So I think next is to get another colour and do the grounds. Okay, so that's all our ground lines done. Now when I've been putting these wires in, I've been putting them all the way plastic insulation down to the board. If you apply too much heat, it will actually melt the plastic back. So keep that in mind when you're doing this, that if you run your heat for too long, it will melt the plastic. Okay, so now we need to work out where we're going to connect this up to. So we could probably use D2 right next to our ground for our PIR. Makes a nice short wire. Okay, so that's the trigger line. I think I'll use the upper 4. So for the trigger for the second ultrasonic, I think we might make that one go to D10 and D9 for the echo signal. So that's the echo, and it's going into D9. This is the echo on the second sensor. So it goes into D11. And this is the last one. So next trick will be to mount everything in there in the chest cavity. Unless I put the plugs on the other end of these cables first. Might even do that. I'll just grab the tools for that. Okay, so I've run into a slight technical problem. The two ultrasonic sensors that I've got, the holes for mounting are far too small for the little screws that I had. Not that I had enough of them anyway. So I've been on eBay and I've placed an order for some more, but it's going to be a week or two before I see those. So while I wait for those, I'm going to use hot melt glue to hold them in place. And I'll use hot melt glue to hold my Arduino in place as well. Okay, so the next thing I've got to do is mount the front plate back in here with the Inmoov logo and mount it back onto Fread. So this has been a pain to install every time I've done it, so I might just do that one off camera. Okay, so I've got that plate mounted back in there. I've also moved this Arduino board up a little bit more so that I can get the plug in for the mini USB to clear this part here. So next thing to do is to mount it on to Fread's chest. So here we have Fread, and this is the mini USB. Now this threads all the way down from the top of the head down through the neck That's the black one there. And then comes out the little hole in the chest. Okay, so that's the chest plate mounted and connected up. When I power up the Raspberry Pi, the Arduino Nano will get its power from the Raspberry Pi, and that'll allow the PIR and the two ultrasonics to operate. This video has gotten to be pretty long, so I'm going to call it quits on this video now. And do the programming to actually test out the PIR and the ultrasonics in a separate video, probably attached to the head series. I might call this quits on this series. Starting from here on out, I think I'll do the rest of the torso, the upper stomach or the top stomach, and attach all of that when I'm finished. I'm still going to have to continue on the head series of videos because there's a lot of programming to be done there, including the testing. So I think the next video I do on the head series will be the testing of the ultrasonics. To see when that video comes out, or any of the others, don't forget to click on subscribe and ring that notification bell. I have a Discord channel, the link will be in the description, along with the links to the various series playlists of all of the videos for the construction of this version of Fread, the Inmoov robot. And we'll see you on the next video.